So we're going to start graphing rational functions. Now, a rational function is just, or rational numbers, I should say, are just numbers that can be written as fractions. So we're going to start talking about some functions that may have fractions in them where x is in the denominator. Now, we're going to do a quick warm-up. And the warm-up here, it says to determine the reciprocals of the following problems. Now, reciprocal just means flip the fraction over. That's all it is. Keep it simple. So if we look at part A here, the current fraction is 1 over 10. So the reciprocal would be to flip it over. We would get 10 over 1, which is just better known as 10. Okay. Now, I'm obviously not going to say that 1/10 is equal to 10, so I just left a little space here to show the fraction being flipped over and then what the fraction reduces to, if anything. Part B, go ahead and flip that fraction over. The reciprocal will be 100 over 1, which, again, if I just take 100 divided by 1, I just get 100. All right. I was about to say number 4. How about part C, which is number 4? Now, when I say flip the fraction over, you might look at part C and say, there is no fraction. You're right. There isn't one that we can see, but mathematicians are lazy. And there is a denominator here that we didn't write, but we could write it. And that would be 4 over 1. All right. You can always put a denominator of 1 under any term, any fraction or any number, any variable. You can always put that denominator of 1. So that creates 4 over 1. So if we flip that fraction over to create the reciprocal, it would be 1 over 4. Now 1 over 4 is not going to reduce for us. So we're just going to leave it. We can do the exact same thing for part D. This would be 50 over 1. As a reciprocal, then it would turn into 1 over 50. Cannot be reduced. And part E here is the last one. We've got 0. So I can put 0 over 1. As a reciprocal, then it becomes 1 over 0, which we've got some problems with. All right. 0 divided by... no, try that again. 1 divided by 0. I got to say it in the right order. 1 divided by 0 mathematically does not make any sense. So what we say mathematically is that this is undefined. All right. It has no mathematical meaning when you try to divide by 0. So we just mathematically say it's undefined for various reasons. So dividing by 0 is undefined. Everything else has a reciprocal of some kind. All right, so moving on to graphing rational functions here. We've got 3 tables of values. We've got some negative values, integer values here. We've got some positive integer values here. And then we've got some kind of weird fractions going on from -1 to +1. So here's the thing. We've got these x values, and we graphed f of x, which is equal to x. So you'll notice these top numbers and bottom numbers match the whole way through. Same thing over here and same thing over here. And what your graph looks like is this pretty, actually let me highlight it. This linear graph right here is f of x equals x. Okay. So that's the straightforward. You guys have worked with linear functions before. Okay. Now it says to use the graph of f of x to answer the following. So I want to know the domain, the range, the x-intercepts, and the y-intercepts. All right. So domain, and I'm going to put this kind of off to the side. Let me zoom in on this. There we go. So domain are your possible x values. Okay. So what values for x could we use for this function? And the answer is everything. So the domain here is going to be everything from -infinity to +infinity. Okay, those are your possible x values. Range are your possible y values. So what could we use here for y values? Again, the answer is everything. Now that's not true for all functions, but it is true for linear functions. Now, nope, I lied. X-intercept first. Where does your graph cross the x-axis? Well, if we look, it crosses right here at the origin, which is the point 0, 0. And it crosses the y-axis, so the y-intercept is the same point, 0, 0. All right, so we're going to talk about some of these key features, whether it's with respect to the linear function here, just to get us a reminder of what domain, range, and the what intercepts are. But we're going to actually apply these key features to the rational function, the 1 over x. So back to these tables of values. So we were given x, right? F of x equals x. And now we've got g of x equals 1 over x. So this is this reciprocal function that we talk about. So if we look at this first table of values, I'm going to turn each one of these x values, and I want to find its reciprocal. So -6 would be -1 over 6. Keep doing the same thing. So -5 becomes -1/5. -4 becomes -1/4. -3 becomes -1. Oops, changed my color there. -1/3. -2 becomes -1/2, and -1, well, still stays -1, because this would have a denominator of 1, which would still just remain -1. Now, when you look at these values, I want you to think about which is the largest number versus which is the smallest number. And so we want to be careful when we talk about negatives and positives. A -1/6, kind of ignore the negative for right now, is close. Well, I'll do it this way. It is closer to the x-axis than -1 is. So -1 is further away from the x-axis than -1/6 would be when we graph the function value. I'm going to do the same thing for the positive values here, which you're going to get the same numbers, just with positive fractions here. So 1, 1/2, 1/3, 1/4, 1/5, and 1/6. Okay, so again, when we're looking at these function values, 1 is going to be further away from the x-axis than 1/6 is. So when we graph these, we'll have to pay attention to that. Now, the set in the middle is kind of the weird ones. So let's look at these. We're going to find values between -1 and +1, because I want to figure out what's going on here. So -1 we've already figured out is just -1. -1/2, well, if I flip that fraction over, it becomes -2 over 1, or just -2. And then -1/10 would be -10 over 1, or -10. -100 over 1, which would turn into -100. It's a pretty big number. I'm going to skip 0 here for just a second and pop over to the positives. And I'm just going to mirror them, but of course they're going to be positive values this time. So 100, 10, 2, and then 1. Now, we just talked what is the reciprocal of 0, and the reciprocal of 0 is undefined. So undefined. Now, we'll talk about how to graph that in just a minute. So I want to take all of these values here and figure out how to graph them for my g of x function. So I have all of these x values, right, that I'm going to pair up with all of these g of x values that I found, right, the reciprocals for the negatives. And then we've got these x values over here, which were the positive integers, with these g of x values here. I'm just, kind of highlighting so you guys see where I'm going to get these values from. And then the middle set, we're going to do the top, which is going to kind of be a little weird, but we'll figure it out as we go, because we've got some fractions there that might be kind of tricky to graph, but it's going to give us the idea of what this graph is going to look like. And then we have our actual function values, the g of x here, that we will figure out as we go. All right, now this is not going to be a graph that's absolutely perfect, okay, but I want to get the idea of what this graph looks like. I will graph it in kind of that blue color, I guess. Okay, so -6, we want -1/6. Okay, so if I zoom in here, -1/6 is going to be pretty close to the x-axis there. And then if I go -5, it's a little further away, A little further away. -2 is at -1/2. That one's pretty easy to graph. Then -1 is at -1. All right, so I know it's hard to do it, but these are actually getting closer and closer to the x-axis as I go further to the left. Now, if I do the exact same thing for the positives, we started with 1, then we went to 1/2, 1/3, 1/4, 1/5, 1/6. Again, as I'm getting larger and larger numbers for the x values, my reciprocals are going to get smaller and smaller and smaller, and they're going to approach this x-axis. Now, for the set in the middle, when we had positive 1/2 for the x value, that reciprocal was +2. So let me go ahead and mark +2. And then when we had 1/10, which is really close to the x-axis here, we were up at +10. And at 1/100th, which I don't even know how to figure out how to graph that, because mostly I need to get up to +100, and well, this graph doesn't get to +100. And then at 0, it said it was undefined. So I don't have a value on this y-axis, right? Because if I had a value, then 0 would be defined. So the way I'm going to graph this is curve through these values that I graphed. So we're going to have a curve here on the right. And then I'm going to, I don't want to say mirror it because that's the wrong term, but what I did here with these positives, the 1/2 and then +2, and then 1/10 and +10, I'm going to use those same values, but on the negative part. So -1/2 would go to -2, and then -1/10 would be way down here at -10. So let me go ahead and curve through those, and I'll do a quick, I'll finish it out on the other side as well. All right, so that's going to go this way. All right, so that green curve is what's called the 1/x rational function, okay? And that's based off of using the reciprocals of x. All right, so that's all of page 1. I'm going to go ahead and stop the video here. If you've got any questions or concerns, let me know, and I will pick up for page 2 with a separate video for key